This is the tutorial for Chapter 12, Section 3, titled Measures of Central Tendency and Dispersion. So we're going to take a look at the three central tendencies we see especially in middle school, and one of those is mean. And mean is just the sum of the data divided by the total number of data values. It's an average, is another term they use to represent that. And it is the best description of central tendency as long as we don't have an outlier. So if the data set has an outlier and it's still in and we don't take it out of the data set, then the mean is not as good of a central tendency as the other three, or the other two. The median is the other one that is pretty good most of the time. It's the middle value, and so we're going to line the numbers up from least to greatest and find the middle value. And it's good as if the data set has the outlier and we're including that outlier rather than using the mean, we'd go ahead and use the median. And the mode is the most frequent. Sometimes we have no mode depending on the data set, and sometimes we are bimodal, means we have more than one mode if two numbers repeat, and that is the most numbers that do repeat. So we use the mode when we have non-numerical values or when we're choosing the most popular item. So here the problems say find the mean, median, mode of each data set and explain which one you'd end up using, which of these three central tendencies we'd use. So here are the touchdown scores. So we're going to first find the mean, and I'm going to do that by taking these digits, 1, 3, 4, 4, and 3. I'm going to add those all together, and I'm going to divide by the number of digits we see, and that is 5. So I go ahead and add these numbers up. This makes 4, 4 makes 8, another 4 makes 12, and 12 and 3 end up adding to make 15. So I take those numbers, divide by 5, divide by 5, and that gives me 3. So that tells me that the mean is 3 touchdowns. And now we'll find the median. And so the median, I just take those numbers and line them up in order. So 1, 3, 3, 4, and 4. So you're lining them up from least to greatest, and you work your way into the middle. And so in this case, we have a middle number of 3, and so this is the median. So these were the first two values, the next two, and the middle value is 3. So this is the median in this case. And then they want the mode, and so this mode is bimodal. So we have two modes here. The most frequent is 3 and 4 because both of them repeat 2 times. So if none of them repeat, then we had no mode. If one of them had a 1 extra, so if this was a 3 instead of a 1, then 3 would end up being the mode. So in this problem, I'm going to actually add an extra value here. Let's go ahead and add another, let's see here, none of them repeat, so I don't want 1 to repeat. Let's make it 7. And so $7 is the price per pound here, and we have 38, 2, 5, and 6. And so when I go ahead, I needed to say which one's the best central tendency. We're going to go with the mean is the best central, actually in this case we go with all of them are pretty good, but we'll say the mean and median are probably the best central tendency. So we'll say mean and median are the best because first of all they're the same, but then there's no outlier, and since there's no outlier, I'd go with the mean, but since they're both the same, I'll just go ahead and state both of them. So in this problem, I'll go ahead and add them together. So I have 38, 2, 5, 6, and 7. So I'm adding these values up, and I'm going to divide by 6, not 2, but 6. Because there are 6 numbers in the data set. So we have 1, 2, 3, 4, 5, and 6. So this makes 40 here. And this makes 40, or 51. And then I'll add on this extra 8. So 50, or extra 7. So 51 and 7 make 58. So then 40 with the 8 and the 2 is then 11. So it's 51 and 58. 58 over 6. And so we'll just do that division here. So 58 divided by 6 gives me 9 2/3. So we'll say 9 2/3, 9.6 repeated, is the mean. And so moving on to the next one, the median, we'll go ahead and line the numbers up from least to greatest. So I've got 2, 5, 6, 7, 8, and 30. And so this 30 represents an outlier. This is an outlier because it's far away from the rest of the data points. See, everything else is just a single-digit number, and 30 is quite a distance from all of these other values. And so in that case, we're going to say the median is the best data set. And the reason why I added this extra number in here is that you can see how when we have an even set of numbers, there are two numbers that are in the middle. So the middle number, the median, is always just one value. So the way you do that to find out what that median is, in this case it's not so hard because they're right next to each other, but you would add them together, divide by 2, and that gives you what the median is, and that's 6.5 for the median. And so I would say this is the best central tendency, and we'd say this is the best one, and the reason is because of the outlier. And so we'll say because, that's our symbol for because, of the outlier. And since there's that outlier, the mean is not as good of a central tendency. There is no mode in this problem because none of the numbers repeat. So that is dealing with mean, median, mode. Let's go ahead and take a look at the next problem, and that says here to find the value of x such that the data set has the given mean. So now they're giving us the mean, but they don't give us all the numbers. So what we have to do is take all the values that we have and add them together, including the x, and divide by the number of numbers, 1, 2, 3, 4, 5, and set that equal to what the mean is. And so the first step I'm going to do is I'm going to go ahead and get rid of this denominator of 5, so I'm going to multiply by 5 on both sides. So when I do that, I end up with the 7 4/10 times by 5, and that gives me 37. So now I have 37 equals. Now I'm going to sum all of these digits here. So here I have 11 plus 12 plus 5 plus 3. So I can see all those digits I added there makes 31. So I have 31 plus x equals 37. So when I go ahead and subtract the 31 from all sides, it's going to give me the missing value to make 7.4 the mean, and that is 6. So we have the same sort of problem, it's just in a different format here. It says the table shows basketball players' scores in 5 games. How many points must the basketball player score in the next game to achieve an average of 13? So the average tells us that we're trying to find the mean. So we want 13 as the average. So the first thing I'm going to do is add these numbers together. And so I'll go ahead and add 10. So we'll clear this screen. We've got 10 plus 14 plus 8 plus 18 plus 11. So I can see in the calculator here 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5 numbers. And so I sum those together, that makes 61. And so now it's saying in order to, these are the first 5 games, in order to get an average of 13 after this next game, we'd need to add on the next game and then divide that by the total number of games, which is now 6. So the 5 and the 1 extra game makes 6 games. We want to average at 13 points. So the first step I'm going to do is the same thing as last time. I'm going to multiply by 6 to cancel out the denominator, do the same thing on this other side. So this ends up giving me 78. 6 times 3 is 18. Carry a 1, makes 78 equals 61 plus x. So I just need to subtract the 61 from all sides to give me the value of x. X is 17 points. And so on the next problem, we're going to end up, there it is, it says that we've got a situation in which we've got this frequency or this line plot. And so I'm supposed to find out what the mean, the median, and the range are of this data set. And so these are the number of students. So 19 represents the number of students here. And in there, the number of students in a homeroom at Jefferson High School. So 19 students, there are 4 groups of that. So in order to find out what the mean is, I need to take 4 times by 19, because there are 4 groups of 19. And then I'll have to add on, it looks like there are 5 groups here, 5 classes that have 20 students in them. And then I'll add on there, it looks like there are 6. 1, 2, 3, 4, 5, 6. So 6 classes with 21 students. 2 classes with 22. And then 2 classes with 23 students. And the last one class at 24. And I'm taking all of those numbers, that's the sum of all the digits, and I'm dividing by how many classes there are. So I count up the numbers that I multiplied these number of students by. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm dividing by 20. So we'll go ahead and multiply out some of these numbers here. 4 times 19 gives us 76. And this one's going to give me 100. And the next one's going to be 126. And the next one's going to be 44. And then we have 46. And the last one is 24. And I'm again dividing by 20. So let's go ahead and add these numbers up. And so I have 76 plus 100 plus 126 plus 44 plus 46 plus 24. And so when we get that sum, that's 416. And now we're dividing that by 20. And so this is going to end up giving us our mean of 20 8/10. And that's how many students we have. And so that's the mean. 20.8 is the mean number of students in our classes. Now we're trying to find the median, so we're taking all those digits. 19, 19, 19, 19, and then we have 20, 20. That should be a 20 instead of the 22 there. So I've got those 5 20s, and then I've got 6 21s, 2, 3, 4, 5, and 6, and then 2 22s, 2 23s, and 124. And then I just kind of work my way into the middle. And so when I'm working into the middle, I just kind of cross off some numbers as I go. And then I see that the 2 middle numbers are 21 and 21. So that tells us that 21 is going to end up being our median. And for the range represents how many values, the distance between the lowest number and the highest number. So I just subtract these two numbers. The highest number was 24, the lowest number was 19. I'm going to subtract those two numbers. That's going to give me my range. So I have a range of 5 students from the highest class to the lowest class. So those are the types of problems we're going to see on tonight's assignment. Good luck.